Hello and welcome to this section of the TI-89 Calculator Tutor. Here we're going to use the calculator's graphing abilities to find the arc length on a graph. And let me show you what I mean by that. Let's go into y equals. Let's put negative x squared plus 4. Negative x squared plus 4. So we're going to have an upside down parabola shifted up. And so we'll see that here. So it's kind of like a mountaintop. When we talk about the arc length, something you mostly learn about in calculus, but you might talk about it in your algebra class. The arc length is basically, it's literally what it sounds like. If you could put a tape measure on top of this arc and curve it, it would be the distance that you would measure. Now obviously this is a curve, so it would be really difficult to put a tape measure and measure it accurately, but if you could get like an ant or something to crawl along this guy and measure the straight line distance, or I should say the curve distance as we go along this curve, then you would find the arc length. So it's literally a distance in every sense of the word, meters or whatever, but it's along this curved path. So obviously this is a longer arc length than this little tiny segment up here. That's basically what we're trying to do. So we go into the math menu, we go down below inflection, below distance, below tangent, because we've already done that, to arc. So we hit arc, and it's asking us for a first point and second point like normal. So we hit enter, we go over here. So when I anchor it here, it's going to find the arc length distance from this point that we've anchored all the way to my new cursor point. It'll think and calculate for a second and come up with an answer and just show us right here on the screen. And the arc length distance is 4.63454. And you can find this answer usually in the techniques of calculus. There are equations that you can take with this function and dump it in there and calculate the arc length. But it's very nice for the calculator to have that functionality built in. Let me show you one more thing. What we can do here is go down to number, it's actually B for arc, and show you that we can do the same thing, but instead of using the trace points, you can type in a number. Let's say we want to go x is equal to 1. So it'll put the point there. Notice it snaps the cursor, and the number that it puts here is not exactly 1. Don't worry about that. It's still going to calculate the answer correctly. It's just snapping the cursor to the nearest point. So we go over here. Let's say we want to find the arc length between these 2 points. Can't quite get on exactly on 3, so we'll just type in 3. It'll think for a second and calculate the arc length distance between them. So this guy right there. And that's really all there is to it, to calculating arc length. It's just a nice function and feature to test your work in calculus, to check your work. Usually in calculus you have to do